Let's look at final exam, question number 38 in Physics Demystified, second edition. If you have the printed book, please see page 521 for the question and page 522 for the relevant illustration. Figure exam-6, which I have reproduced here in simplified but color-enhanced form. Basically, we're talking about a substance here that starts out as a liquid, and we warm it up, and we keep adding heat energy to this liquid sample. The temperature rises and then levels off for a while, and then continues to rise once it becomes a gaseous substance, like, for example, boiling water. The temperature of the liquid itself, no matter how much heat we're applying to the burner in a kettle of boiling water, always remains at the boiling point of water, roughly 100 degrees Celsius at sea level on the Earth, or 212 degrees Fahrenheit. We all pretty well familiar with that phenomenon. By the way, if you go to altitude, water will boil at a lower temperature than it does at sea level. That's why you need, if you're hard boiling or soft boiling eggs, and you'll need to do it for a little longer on top of, say, Mount McKinley than you'd need to be doing it at sea level, say, in San Francisco. Anyway, liquid temperature levels off, then the temperature of the gas, the vapor coming off, can rise indefinitely again. What is this graph showing us? What phenomenon, what property of the substance is this graph illustrating? The answer to that question is D. This is illustrating heat of vaporization. Heat of vaporization. It isn't telling us exactly what it is, even with the numbers on here. It doesn't tell us precisely what the heat of vaporization of the substance is. Figure exam-6 has numbers on these scales, but even so, we'd need more information to actually quantify that, but it is an illustration of the phenomenon known as heat of vaporization. So the correct answer is D.